Continuing with section 3 in chapter 7, the standard normal probability distribution. Given the techniques discussed in the videos before, you should be able now to confirm the answers to all these questions in slides 15, 16, etc., 17, all through slide number 24. In slide 25, you have a slightly different problem. Using Z to find X for a given probability. An example. Leighton Tire and Rubber Company wishes to set a minimum mileage guarantee on its new MX100 tire. Tests reveal the mean mileage is 67,900 with a standard deviation of 2,050 miles, and that the distribution of miles follows the normal probability distribution. Leighton wants to set the minimum guaranteed mileage so that no more than 4% of the tires will have to be replaced. What minimum guaranteed mileage should Leighton announce? On the next slide, you have the normal distribution here drawn for this case. The mean is right at 67,900, measuring, of course, miles here on the horizontal. And if the company doesn't want to replace more than 4%, so the 4% that they're looking at is in this shaded area here, is the lowest 4% in the distribution. Well, using basic knowledge of probabilities from the normal distribution, remember all the area from the mean to the left must be 0.5, as shown here. And since we know that this area must be 0.04, the area between the mean and the x value that we're looking for should be 0.46. Now you have a section of your table here, and I have on the website the table for the standard normal distribution. Notice how on the first column, as the value of Z increases, the value of the probability increases, or the area under the curve, logically, because the Z value will be farther away from 0. And we're looking for an area, remember, that is 0.46 between 0 and the corresponding value of Z of X. And in this case, by the way, it'll be a value of Z that should be negative because it'll be to the left of 67,900. Okay, so if you go down the first column here, what is the value that is just below 0.46? If you notice, it's right here, 0.4554, next to 1.7. As you move to the right, this value should increase. Okay, and notice this is the closest to 0.46, 0.4599, and it's under 0.05. So the value of Z should be 1.7 plus 0.05, so it'll be 1.75. Okay, and that is also shown in your slides. This is the value of 1.75 that yields an area of 0.4999 between 0 and the value of Z of 1.75. Well, you replace that in the formula. Z is equal to X minus mu over sigma is equal to this, given the values of the problem. And then replace the Z value with minus 175. And then it's just a matter of solving for X. Okay, multiply by 2,050 on both sides, and then you add 67,900 on both sides. The answer is 64,312. Now in Excel, the command that you can use to find the Z value given a probability, a specific probability, is norm.s.inv for inverse. Remember, we used dist before. That is to find a probability given a z-value. But now we need to find the z-value given a probability. So we now specify that this probability is 0.04. And we get the 175 negative. Okay. Now, after you find this value, then you substitute it here and solve for x and find 64,312. However, you can find that x value by using the general command for normal distribution, norm, but you need to use the inverse too, okay? Because you are trying to find an x value in a normally distributed x variable, okay? So open parentheses and type, what is the probability? 0.04, comma. What is the mean? Well, in this case, 67,900, comma. And then what is the standard deviation? 2050. Close parentheses, hit enter, and you get your answer, 64,311. Now on the slides you also have this version. You can also use in Excel. Click on formulas, and then here you look for more functions and look for statistical function, okay? And here look for the norm command. Notice norm and inverse, and then the standard normal with the inverse. So look for the norm inverse and enter. Notice this is a cell that I'm using. Enter the probability the same way we entered before, 0.04. This is just another way of doing it. And then the mean, 67,900, and the standard deviation, 2050. Notice you get the answer right here, 64,311.09. Okay, click OK, and that is the answer. Sometimes this tail is on the other side. You need to find the value on the upper tail. Okay, it depends on the characteristics of the problem. All right, so that is the last part of chapter 7.